that they cannot do a certain thing. Or if they do, you have an opportunity to make infinite money. Okay, so this is going to be lemma 4.5. Which says if t is a non-negative super martingale, then Tn converges almost surely. So if you remember how we are reinterpreting this convergence, or at least the almost surely in the game theoretic framework, is it means that we can force it. So we have a strategy that gets infinite money if it doesn't happen. Okay? We have a strategy that cannot go bankrupt. And it makes infinite money if Tn does not converge. So that's the meaning of almost surely in the game theoretic framework. This will be one of the building blocks we're going to use in showing this statement. And this is the upcrossings tool. That's the major one. Let's see how it works. Let's be a little bit more precise about this convergence, because what does it mean to converge? It means that so this almost surely means that it's actually an event. So whether Tn converges or not, it depends on the path that we're on. So you're converging on a path or not. So let's pick a path in the sample space. So you converge if the limit of n to infinity of t on the prefix of length n, right? So t was a process because it was a super martingale, so it's defined on all the finite lengths. If you take the limit along the path of how large t is and take the length to infinity, that has to be defined, first of all, and it has to also be not infinite. So it has to be defined and finite. So this, in a way, it says that if you look at something that is a capital process, or a little bit worse, but let's think of a capital process, then if that amount of money that the process has, so it's the process of some strategy, if the amount of money keeps on going up and down, that's really, really weird. And you can fix it, you can do something about it, and make that never happen. So previously we were thinking about what happens if the capital actually does this. And we said, oh, if that happens, we can make a capital process that gets rid of these weird drops, and it just keeps on growing. So now we're looking at a different situation where, what if we have a capital process process and it does this. So we don't get, it never gets infinitely rich. It just keeps on going up and down. So this is going to say, that is so fishy it cannot happen. So you can't do that, and the reason that you can't, well, it can happen, but then you can fix it easily by making a transform strategy that gets infinitely rich. Okay, so how does that work? So, the first thing that's going to happen is that if we assume it doesn't converge, we know that a picture like this will happen, but we don't really know where. These oscillations that prevent the convergence may happen at any level, at any capital. Right? So we don't really know where it happens. But we know that there are two boundaries where you're forever going to go below and then above the high one and below the low one and above again. These exist. So from the not converging, we know they exist. So let's first think about if we know where they are, and then think about if we don't know where they are. But that's going to be, as before, we put an investment in a small one in all the possible places where these things can be. And we do forcing of the countable, how do you say it, network, or a countable sequence that covers all the possible cases where these bounds can be, where you forever fluctuate. So let's first think about how to do it if you know these two bounds where you're forever fluctuating. So let's call them A and B. And it's nice to take them rational, because then later we can have countably many choices and we can put money on all the papers. Okay? So we're going to make a strategy that gets infinitely rich if T, which is another super martingale, wiggles forever between A and B. I mean, a little bit below A and then above B, below A. So how do we do that? Well, let's do the intuition, the most important. So T is going to go above B at some point. And all the way that it's going to do that, let's say it starts from somewhere, it's on the way up. Right? Then we know sometime later it's going to be below A. We don't know exactly how it will get there, but it will get there somehow. And then it will go up again. And then it will go down again. So the idea is that if we know it's going to go up, down, all the time, and it is a strategy, or it is a capital process, so there is a strategy behind this, then let's follow that strategy on the parts where it's going up, and let's just not invest the time when it's going down. And then when it's going up again, we invest, like the strategy does, and then when it's going down, we do nothing. So we only get the amount of up that the strategy behind T was securing, and we don't suffer the amount of down that it gets, because at those times we're not investing at all. So if the picture indeed looks like this, forever bouncing between A and B, then we are getting all the amount of up, and that's an infinite amount. Yes?
Are you assuming here that this process, I mean the underlying process is oblivious somehow? Because, I mean, you're changing your strategies.
Yes.
So then nature and reality can change things as well, right? You're announcing different extents.
Hold on. sounds like it should be not an issue, but let's see. So there is this strategy behind T, right? We fixed that, it's a fixed strategy. And we're going to make a new one with a certain guarantee. And now you're saying, oh, but now you're changing what you're doing. But I don't think that's a problem as long as we guarantee what we want to guarantee. So there are these two pictures at the moment. We have T, which is some sort of an input process. That's what you get if you do a certain strategy and burn some money. That's what it really means in supermarket deal. But it's always nice to think about the sharpest case, where it's just the capital process of some strategy, no burning. So there is something like that, and that just has a certain behavior on all possible ways that nature can play. Right? And we are going to build another strategy and have a guarantee that it also has a certain behavior. And that's true. There are now two strategies sort of in the air, but we're never assuming that reality was playing sort of a smart response to one of them. We're always saying we can guarantee that no matter what happens, that something will go on.
But can you really know when T is going? Like, do you know in advance? Or if I follow this strategy T, then it's